Hello and a very warm welcome everyone to day 12 of LDCE ADSTE preparation. So this is Prashant Goklani and I welcome you all to this exclusive series, and we are discussing LDCE 2009 paper solutions from last few videos. Really sorry for the delay that happened in uploading this video. Anyways, the topics that we are going to discuss in today's video are waveguide, microprocessor, isolation transformer, router, and amplitude modulation. So these are going to be the topics for the day. And apart from it, so an interesting thing to note here is that probably for the very first time we are going to discuss all the topics from the telecom department. Till now we were discussing questions mostly on signal department. So without any further ado, let's go to the question paper first and have a look on the exact question. So here is the question: write short notes on any three: waveguide, microprocessor, isolation transformer, router, and amplitude modulation. Right? So this question carries 15 marks and you have to write short notes on any three of these 5 topics that have been mentioned here, and each short note would carry 5 marks as is very evident from the marking scheme itself. Okay, so let's go to the first topic and see what exactly it is. So the first topic is waveguide. You can refer to ERISET note T6 EM wave propagation and antennas, chapter 4 VHF or UHF antennas, and you can go to page number 52. You would find a mention of waveguides in this particular page and in this particular chapter, but you won't find the exact definition of waveguide in this particular book or in any of the other ERISET notes. So what I have done, I have got some good links with me where you can find a good definition, a detailed definition of what exactly a waveguide is, so that it serves two purposes. It would first let you understand what waveguides are, give you a clear definition so that you can write it in your answer sheet, and also you can find other points like advantages, characteristics, diagram, and other things associated with the question that you can write it in your answer. So let's go ahead and have a look on the definition of waveguides first. So you go to Wikipedia or you can go to Google and write waveguide, and most probably the first link that you will get would be of Wikipedia. And just a second, so I'll go to this. So waveguide, as per the definition of Wikipedia, is defined like this: a waveguide is a structure that guides waves such as electromagnetic waves or sound with minimal loss of energy by restricting the transmission of energy. Just a second. By restricting the transmission of energy in one direction. Without the physical constraint of a waveguide, wave amplitudes decrease according to the inverse square law as they expand into three-dimensional space. So 2-3 important points to note down here. First, waveguides are structures that guide waves, right? And especially we are talking in terms of electromagnetic waves, right? And with minimal loss of energy by restricting the transmission of energy in one direction, by restricting the transmission of energy to one direction. Okay, so what exactly does the waveguide do? It restricts the direction of energy. It restricts the direction of energy in one direction, and without the physical constraint of a waveguide, wave amplitudes decrease according to the inverse square law. That means as the distance would increase, the amplitude of the wave would decrease according to the inverse square law, right? So this is an introduction, or this is the definition of waveguide that we can refer to. Now in this particular definition, generally one or two things are important in this. First of all, when we are talking about electromagnetic waves, specifically we are talking about waves with higher frequency, okay, like VHF, UHF, and microwave frequencies. In these type of signals with high frequency, the bandwidth utilization is high as the signal provides more space for other signals to get accumulated. And these high frequency signals can't travel longer distances without getting attenuated. So this is something which you should note, that higher frequency signals cannot travel to longer distances without getting attenuated. And how is the attenuation, what is the amount of attenuation in this particular signal? It varies according to the inverse square law that we already studied. Right now, let me just show you a simple diagram of a 2-port rectangular waveguide. So this is port 1 of the waveguide and this is port 2 of the waveguide. Okay, so from port 1 the wave enters and from port 2 the wave exits. And the purpose of the waveguide is to cause minimum attenuation to the wave by restricting the energy of the wave into a single direction, Okay, now what are the main characteristics of a waveguide? So these are some of the important things that you should remember for your answer writing, right? So the first important point is the definition of waveguide. The second important point is the main characteristic of a waveguide. The main characteristics of a waveguide are: the tube wall provides distributive inductance. Okay, the empty space between the tube walls provide distributed capacitance, and these are bulky and expensive. So these are the three characteristics of waveguide. Advantages of waveguide are: following are the few advantages of waveguides. Waveguides are easy to manufacture. They can handle very large power in kilowatts. Power loss is very negligible in waveguides, and they offer very low loss, low value of alpha or attenuation. And when microwave energy travels through waveguide, it experiences lower losses than a coaxial cable. Okay, so if you transmit waveguides, if you transmit microwave or VHF and UHF frequency signals through a coaxial cable, then probably you would get very high energy losses compared to a waveguide. So these are some of the advantages, that power loss in waveguides is very negligible, and they have low attenuation, and they can handle high power, right? Now the types of waveguides, this also is important for your answer. There are 5 types of waveguides: rectangular waveguide, circular waveguide, elliptical waveguide, single ridged waveguide, and double ridged waveguides. You can refer to the following the types of waveguide in the diagrams below. These are simple to draw. So if you draw it in your exam, if you have enough time to draw these figures in your exam, then it adds a lot of value to the answer, right? Other than that, there is nothing else which is required to be written. Okay, so that's it. This was the first topic that we have covered. Now let's have a look on the second topic. So the next topic that we are going to talk about is microprocessor, and you can refer to research note T5B, microprocessors and application, chapter 1, introduction, page number 3, for getting a detailed note about microprocessors. Okay, so I'll just open up this particular, just a second, I'll just open up this particular file. So here is the short note on microprocessor. Okay, so as you can see, chapter 1 talks about microprocessor. First of all, what is the definition of microprocessor? This is very important. If you form your answer in a very organized manner, then it makes a good impression on the examiner, and for you also it's very easy to understand and recollect whatever you have studied. Okay, so what is a microprocessor? A microprocessor is the name given to a semiconductor logic IC chip which is developed through VLSI technology of IC making. The main feature of this chip is its programmable logic. The meaning of programmable logic can be explained as below. Important things, I'll just take the highlighter and highlight the important things. Okay, so the first thing is, microprocessor is the name given to a semiconductor logic. Semiconductor logic means in terms of zeros and ones, it's an IC chip which is developed through VLSI technology of IC making. So this is the first important thing that you should note for your definition purpose. Okay, so and the main feature of this chip is its programmable logic. Okay, the main feature of this chip is that that it's a programmable its programmable logic. Okay, now a microprocessor is designed to perform numerous logical, arithmetic, data transfer, decision making and system control function, but all these can be offered to a user only on demand from him through a program. The functions to be offered and their order of execution is decided by the user based on the requirement for an application. This type of working logic of any device is called a programmable logic. Okay, so there are many types of functions that are present in a microprocessor, like logical, arithmetic, data transfer, decision making and system control function, but all these can be offered to a user only on demand from him through a program. The functions to be offered and their order of execution is based on the program that the user creates, and this is what is called a programmable logic. Now if you see the basic diagram or block diagram of a programmable logic, here is what of a programmable system, here is what it looks. So you have input on the left hand side, you have a CPU or a microprocessor in between, and you have a output, and in between you can see that the microprocessor interacts with the memory for fetching, reading and writing the data. Okay, so once you get an input from the user, the function of the microprocessor is to get the data from the input, do the necessary function or do the necessary logic on that particular set of input and give the output. Okay, so that is what, and whatever is the data that it deals with comes from the memory. Okay, so this is what the block diagram of a basic programmable system looks like. Okay, now microprocessor, this is the functional logical symbol of microprocessor. Microprocessor basically has three buses: data bus, address bus and control bus. So the buses are nothing but a medium to transmit various sorts of data from the microprocessor to other devices. Okay, for example, data bus is a series of transmission media through which the data is transacted, and it is bidirectional, as you can see. Address bus is basically a set of transmission media through which microprocessor gets the address of the data which it has to read or write. Okay, and last but not the least is the control bus through which the microprocessor gets the status commands gets and gives the status command to the various devices attached to it. So this is what the functional symbol, logical symbol of a microprocessor looks like. Now, essential units of microprocessor. So this is very important to know about the essential functional units which are there inside a microprocessor to make it a full-fledged central processing unit in a computer or in any other programmable system are the following. So here are the following components or following units of a microprocessor. First of all is ALU, arithmetic logic unit. So as the name itself signifies, that arithmetic logic unit basically is the unit of the microprocessor which deals with the arithmetic and logical operations. Arithmetic as in addition, subtraction, multiplication and division. Logic unit is nothing but operations like AND, OR, NOT, XOR and so on and so forth. Okay, so this is what is the function of an ALU. Apart from it is an accumulator. So what is the function of an accumulator? An accumulator is an important special function register which is very essential in every microprocessor. Okay, so it's a very special functional register, important functional register which is essential in every microprocessor. The name accumulator is given to the register because it accumulates the result after every arithmetic or logical function in the ALU. Its main function can be stated as below: storing the result after an arithmetic or logical operation and sending and receiving data to and from a external IO device. Okay, so these are the two main functions of the accumulator. Important things to note about an accumulator is that it's an important function register which is essential in every microprocessor. This is the first thing. And the result of every arithmetic or logical function in the ALU is saved in the accumulator. Apart from it, the other function that an accumulator does is sending and receiving data to and from an external IO device. Okay, then other than that, there is a flags and flag register. Flags are individual flip-flops used for storing bit values. These flags are provided at fixed bit positions in a register called flag register. Okay, so what is a flag register? Flag register is the status register in a microprocessor that contains the current status of the processor. So this is an important thing that you should note. Other than that, you don't need to remember the whole description. The important thing to note is flag register is the status register in a microprocessor that contains the current status of the processor. Then you have instruction decoder and execution unit. So during a program execution, the microprocessor fetches reads from memory individual instruction of a program one by one in a sequential order. Each of these instructions is fed to an instruction decoder for the purpose of understanding the function of instruction specifies. This means the instruction decoder basically translates or decodes an instruction so that execution can understand it and execute the function specified. So whatever is the program that you will code inside the microprocessor, the instruction decoder basically decodes it for the purpose of understanding of that function, that what exactly is the instruction that has been specified. It translates an instruction into an instruction so that the execution unit can understand it and then execute it. Okay, and other than that, there are various types of microprocessor depending upon the number of bits that they deal with. There can be 8-bit microprocessor, there can be 16-bit microprocessor, 64-bit microprocessor, so 32-bit microprocessor. These are all the types of microprocessors that you get. So there is a lot more that has been mentioned in this chapter. You can go through this full chapter, but I have given you a brief description about what you can write in this short note. First of all, you can talk about what is the basic definition of a microprocessor. So as I discussed, the basic definition of a microprocessor is that it's a semiconductor logic IC chip which is created through VLSI circuit designing, and it basically works on programmable logic. So the next topic that we are going to discuss today is isolation transformer. Now isolation transformer is also something which I could not find any mention of it in any of the ERESET notes, but I got a good amount of content from the internet, and especially from ABB, from one of the PDFs by ABB, and where I could get a good description about the isolation transformer and its application in the Indian Railways. Okay, so what exactly is isolation transformer? An isolation transformer is a transformer used to transfer electrical power from source of alternating current power to some equipment or device while isolating the power device from the power source. Okay, usually for safety reasons. So isolation transformer, as the name itself signifies, that there is the isolation, okay, that is provided in the transformer from the source of alternating current power to some equipment or device while isolating the power device from the other source. Okay, so whatever is the source of the alternating current power to some equipment, whatever it may be the equipment, so there is an isolation between the source of alternating current and the device which is powered by this power source, usually for safety reasons. So there is an isolation provided for the safety reasons. And isolation transformer provide galvanic isolation. Okay, no conductive path is present between source and load. no conductive path is provided. So this is the isolation that we are talking about. The source is the transformer, and the load is some device, and there is an isolation provided between these two, just a second, these two things. And what is the reason? It is the isolation is provided for safety reason, right? And this isolation is used to protect against electrical shock, to suppress electrical noise in sensitive devices, or to transfer power between two circuits which must not be connected. So in these three situations we provide an isolation transformer. What is the first situation where you can provide an isolation transformer? The first situation can be protect against electrical shock. So the device which is at load, you don't want someone working on that device to get an electrical shock. That is why you isolate the alternating power source from the device that is going to be powered by this source. So this can be the first situation in which you want to use this isolation transformer. The second type, or the second situation in which you can use the isolation transformer, is to suppress electrical noise in sensitive devices, right? So due to a direct contact between the AC power source and the device which is being powered, there can be a noise due to the AC power source. I don't want that noise, and that is why I isolate the AC power source and the device that is going to use it. The third situation can be auto transfer between two circuits which must not be connected. Okay, so this would be the third case. I don't want the AC power source and the device which is going to be using this power to be connected, right? And that is why I provide a isolation transformer. These three are the situations in which you can use an isolation transformer. Okay, and I have defined the isolation transformer also, in which cases it is used. Now let's understand the application of isolation transformer in your Indian Railways. So in isolation transformers are special transformers which are used to isolate the AC network from the DC leakage currents caused by the DC rails in close proximity of the AC rails. Now in the fully electrified RE area, you know that the traction return currents and the DC track circuits are working simultaneously, right? So this is specifically for the areas which are using DC track circuits. Okay, so on the same rails, many times it is happening that the rails on which the traction return current is flowing and the DC track circuit current is flowing are very close to each other, and you don't want the DC leakage currents or DC rails, the DC current to interfere with the AC rails, and neither do you want the AC rail current to interfere with the DC rails. And in that particular situation you use the isolation transformers. Okay, so this is the application of an isolation transformer in Indian Railways. Now let's talk about the second last topic, basically router. Okay, so router is a networking device, as most of you already know, and most of you use it, right, for your day-to-day Wi-Fi purposes or Wi-Fi application. You can find a mention of routers in T17V data networks of IR in the reset note. If you want to refer, I'll mention the description, or I'll mention the link for all the reset notes that are mentioned in this particular PowerPoint presentation in the description of this video. So don't you worry, you'll get all the relevant reset notes related to the particular short notes in the description of the video. Anyways, so I'll just go to the link first, the reset note first, so to show you. So page 8 I guess was the page that we had to refer to. Okay, so just a second. So this is what we are going to refer to. Now routers, a router uses a combination of hardware and software to actually route data from its source to destination. The important thing to note here is that the a router deals with layer 3 addresses or the IP addresses. Okay, so a router basically routes the packets from the source to destination with the help of the IP addresses. Okay, routers actually have a very sophisticated OS that allows you to configure their various connection ports. Okay, and routers are used to connect remote LANs together using WAN technologies. You can connect remote LANs together using a WAN technology using a router. Now, an important thing about router, I'll just open up the Wikipedia for routers. Okay, so Wikipedia defines the definition of router as: a router is a networking device that forwards data packets between computer networks. Routers perform the traffic director functions on the internet, and data sent through the internet such as web page or email is in the form of data packets. Okay, so whatever is the content that you try to fetch from the internet, whether it may be a web page or it may be an email, it is sent with the help of data packets, and a packet is typically forwarded from one router to the other router till it reaches to the destination network. Okay, until it reaches to the destination node from where it has to fetch the data. A router is connected to two or more data lines from different IP networks. When a data comes in one line, now how does it actually transfer the data packet from one network to another network, or from one source to another destination? It does so with the help of a routing table. So routing table stores all the routes for a packet to travel from one place to another, or one source to one destination. It saves all the routes, and depending upon whichever has the lowest metric, depending on that, it transfers the data through that particular route. Okay, and it's a layer 3 device, layer 3 of OSI. It is a layer 3 device, and you can get a lot of information about router on the internet, so you can refer to the details on the internet as well. Okay, so let's go ahead to the next topic now coming to the last topic for the day, amplitude modulation, a very important topic when we try to understand the fundamentals of communication. Okay, fundamentals of telecommunication, or fundamentals of communication in general. You can find a good overview and a good description about amplitude modulation in T4B module of ADSTE note, that is called modulation techniques, analog and digital. You can find a mention of this particular type of modulation in chapter 1, amplitude modulation itself. It's on page number 3. Okay, so I'll just open up this particular module. Amplitude modulation, as you can see, is chapter 1. Now modulation, first of all, let's understand what modulation is. Modulation is the process in which the amplitude, frequency or phase of a high frequency wave, usually called the carrier, is changed in accordance with the instantaneous value of the low frequency wave called the modulating signal. Okay, so what is modulation? Modulation is a process in which the amplitude, frequency or phase of a high frequency wave, usually called the carrier. So the high frequency wave is called the carrier, and the amplitude, frequency or phase of this carrier wave is changed in accordance with the instantaneous value of the low frequency wave called the modulating signal. So when we are talking about amplitude modulation, in amplitude modulation, basically the amplitude of the carrier wave is changed in accordance with the instantaneous value of the low frequency wave called the modulating signal. Okay, so for example, let us consider okay, so what is the need of modulation? This all you can see, but we'll basically talk about amplitude modulation in this particular topic. So an important thing to know is time domain and frequency domain representation of an amplitude modulated wave. I have already defined what is exactly amplitude modulation. So in amplitude modulation, the amplitude of the carrier wave would be changed in accordance with the modulating signal, low frequency modulating signal. Okay, so let's consider a particular case. Okay, now here is a carrier wave which is represented by the instantaneous amplitude or instantaneous voltage of the carrier wave is given by EC is equal to EC sine omega ct, where capital EC is nothing but the amplitude of the carrier wave, omega c is nothing but the angular frequency of the carrier wave. Okay, and the second thing is EM, okay, which is actually the representation of the modulating signal. Okay, so the instantaneous value of the modulating voltage is given by capital EM sine omega m t, where capital EM is nothing but the amplitude of the modulating signal and omega m is nothing but the angular frequency of the modulating signal. Okay, so now as per the definition of the amplitude modulation, the amplitude of the carrier wave or the instantaneous voltage of the carrier wave should vary in accordance with the instantaneous value of the modulating signal. So an important parameter regarding this is modulation index, okay, or modulation index, yeah, and it is defined by K equal to EM upon EC, where EM is capital EM is nothing but the amplitude of the modulating signal and EC is nothing but the amplitude of the carrier signal. And okay, so basically the modulation index is a number lying between 0 and 1 and it is often expressed as a percentage of modulation. Okay, now in this figure you can see the variation of amplitude of a amplitude modulated wave. Okay, so here you can see it's mentioned EC was nothing but the amplitude of the amplitude of the carrier wave. Okay, now the amplitude, as you can amplitude of this carrier wave is changing in accordance with the amplitude of the modulating signal, as you can see very well here. Okay, so the lowest amplitude here it starts from EC itself, okay, capital EC, and then slowly it goes on increasing as the amplitude of the modulating signal increases. Okay, and the instantaneous value of the resulting amplitude. So now if you want to find out the amplitude of this particular amplitude modulated wave, then it is nothing but EC plus EM sine omega mt, right? So EC plus EM sine omega mt, and you can write EM as K into EC. So K into EC sine omega mt. You can take out EC common, and what would remain is EC 1 plus M sine omega mt. Okay, where M is the modulating index. Right. Now if you try to just a second. Now the instantaneous voltage of the resulting amplitude modulated wave is E equal to A sin omega ct, where A is the amplitude of the signal and omega c is the frequency, angular frequency of the resultant amplitude modulated signal. So omega c the angular frequency would be same as the carrier angular frequency, but the amplitude would be something different. So when I compare this particular form, a particular expression with the expression that we have got EC 1 plus M sin omega mt sin omega ct, and we have got on the left hand side A sin omega ct. When we compare both these, then what do we get? We have got the amplitude, this is the amplitude, and this is nothing but your sin omega ct. Okay, now if we expand this trigonometric relation, then sin x sin y, as you know, can be expressed as half cos x minus y minus cos x plus y. This is the fundamental formula that you can easily remember. Okay, sin x sin y is half cos x minus y minus cos x plus y. So if you if you represent this sine omega mt sine omega ct in terms of half cos omega m minus omega c minus omega m minus omega c plus omega m, this is what the expression you will get. So this is basically the time domain representation of this is basically is the expression of the resultant amplitude modulated wave. And here you can see there are two components, omega c minus omega m and omega c plus omega m. Okay, so there are two side bands to this particular amplitude modulated signal. One is fc minus fm and the other is fc plus fm. So if you try and look at the spectrum of this particular signal, you would see it something like this. So there are three components basically, fc minus fm, fc and fc plus fm. Okay, so this is your lower sideband and this is your upper sideband, and the difference between carrier frequency and lower sideband is fm, and difference between upper sideband and carrier frequency is fm. Okay, so this is the frequency representation of AM signal. And if you look at the time domain representation, this is what it will look like. Okay, so initially you can see the amplitude is nothing but the amplitude of the carrier signal, but as you superimpose the modulating signal on it, the amplitude of this particular wave of the carrier signal starts changing with the instantaneous voltage of the modulating signal, right? So as the modulating signal increases, the amplitude of the carrier signal also increases. Okay, so here you can see the Emax and Emin. Other than that, important thing about this is the power carried in an AM wave. So as you all know, the power is nothing but V square by R. For an AC signal, it is nothing but RMS, V square RMS upon the resistance. So in our case, the power would be nothing but the sum of all the three powers, that is E square carrier by R, E square LSB by R and E square USB by R. So with this, I would like to end this presentation. I hope you all enjoyed this. This is Prashant Goklani, Junior Engineer Signal, signing off. Thank you so much.